So in this question, we've got a velocity graph. And what we want to do is find the total displacement after the first 6 seconds. So remember that the position is the velocity, but with respect to t. Really what we're doing is looking at what's the area under this graph? And that would give me my total displacement in that first 6 seconds. So we're breaking it. We get area of the trapezium, area of the rectangle, area of the trapezium in that respect. So there's the area of the first trapezium, area of the rectangle is 5 by 2, and the area of the second trapezium. So all up, the area under the curve would give me 47.5. So that means total displacement there would be 47.5 centimetres. In question 10, the velocity is given to us by 3t squared minus 12t. So we've got the velocity. Initial displacement is 3 metres. Find the displacement of the particle after 5 seconds. So we've got to get our position statement, we've got to integrate velocity. So that's where this has come from. 3t squared becomes 3t cubed on 3, and 12t becomes 12t squared on 2. We've got to find our constant of integration. We can't forget about that. But we're given that the initial displacement, so t is equal to 0, is 3. X would be 3. So we sub that in. X is 3, t is 0, our constant is 3. There's our statement there for x. X is equal to t cubed minus 6t squared plus 3. Now, after 5 seconds, as it says in the question, we substitute it in, and we get minus 22. So after 5 seconds, the particle's 22 meters to the left of the origin. Acceleration of the particles given as 18 e to the 3t. So this time we want to find the displacement of the particle, which means, well, we've got acceleration, we need to go back to velocity, then we need to go back to the position statement. It's going to integrate exponentials and find our constant. So we integrate using the rules and then find our constants by the data was at rest after 1 second, at the origin after 1 second. So when t was 1, velocity was 0. So we sub that in, we find that c1 would be minus 6e to the power of 3. So integrate again. So there's our velocity statement. We integrate again because it says 6e to the 3. Just remember that's a constant, so that's just going to add a t there and get our second constant to find. And we're told to rest at the origin after 1 second. So when t was equal to 0 at 1, x was equal to 0. And then, so we sub those in, and we get our constant being from that part 4e, because that's minus 4e cubed, so the constant would be second constant would be 4e cubed. So that's our position statement. So when t is equal to 3, we're able to do our substitution in, and we get 2e to the 9 minus 14e cubed. Leave it like that. That's going to be a pretty large number, I would say. And so it's not going to be, that's exact, so that's going to be that value there in centimetres.